All right, welcome to section 1.3, and this is your notes part 3. All right, so this is part 3 of your notes, and we're exploring variables and equations. Again, we're going to take a double look, and before you are done with section 1.3, you'll use variables, expressions, and equations in model situations, and we'll learn how to evaluate or solve expressions using substitution. So, again, a letter that is used to represent a number, and it's a lowercase letter, we call this a variable. All right? A letter used to represent a number, an unknown number. All right, we call this a variable. Now, when variables are combined with numbers and operations like plus, minus, times, and divide, we call this an expression. Call this an expression. And then when we have an equal sign, two equivalent expressions separated by an equal sign, we call this an equation. So anytime there's an equal sign, we have an equation. So examples of variables could be m, x, y, we could have q, t. All right, expressions could be 3x, 2 plus x, 4 minus t, or we could have m over 2. All right, these are all examples of expressions. And then with equations, we could have 2x equals 1. We could have m equals 4. We could have 3x plus 1 equals 6. All right, as long as there's an equal sign, it's an equation. All right, so that equal sign is what makes the equation. No equal sign is expression, and if it's a lowercase letter all by itself, it's a variable. Remember what I said. I said lowercase. All right, lowercase letter, not uppercase. So what I want you to do in class is I want you to look at these examples and tell me, is this an expression, an equation, or just a plain variable? All right, but in this case, just an expression or equation. And then have me check it before you move on down here. All right, go ahead and pause it, do it, and have me check it in class before you move on. All right, so now we moved on to the bottom, and what I want you to do is I want you to use substitution for the variables in these cases. So if we look here, we got x. When x is 1, we're going to substitute 1 in for x. So instead of 6 times x, it'll be 6 times 1, which we did in our notes that we wrote down in your notebook. So when x is 2, this will be 6 times 2, which we said was 12 in our notes we did earlier. When x is 3, this will be 6 times 3. When x is 4, 6 times 4. And then when x is 5, 6 times 5. So we'll substitute that 5 in for the x when x is 5. So it'll be 30. All right? So I'm going to do one more with you, and then I'm going to let you try the other two, okay? So when y is 1, we're going to substitute this y with a 1. So it'll be 2 times 1 plus 1. So everywhere you see a y, we're going to replace it with that 1. So 2 times 1 is 2. And then that 2 plus 1 gives me a 3. Now, right up here, everywhere you see, when y is 2, everywhere you see a y, we're going to put a 2. So this will be 2 times 2 plus 1. 2 times 2 is 4 plus 1. I got my 5. When y is 3, everywhere you see a y, we're going to replace it with a 3. So 2 times 3 plus 1. So 2 times 3 is 6, plus 1 is my 7. Right? I think you could see a pattern happening here, don't you? It looks like it's increasing by 2. So let's see if the next one is 4. So every time you see a y, now we're going to substitute it with a 4. So 2 times 4 plus 1. So 2 times 4 is 8, plus 1 is 9. It is increasing by 2, so I bet you this next one is 11. So what I want you to do is I want you to try the next one. So substitute the b with a 1. Then substitute that b with a 2. Put it in the calculator if you need help. Negative 2 times 1, negative 2 times 2, negative 2 times 3. We're substituting this b with these numbers. Same thing here. You're going to substitute this a, when a is 1, substitute this a with 1. Then substitute this a with 2. Substitute that a with 3, then 4, then 5. Go ahead and try that and let me check it before you move on to the next thing. Okay, now that I checked that work, let's look at this. Find the values of each of these by substituting 2 for x and 3 for y. So that means everywhere you see an x, you're going to substitute a 2. Everywhere you see a y, it'll be 3. Everywhere you see a z, it's going to be 5. Okay? So right here, we got 3 times z. Well, what is z? Z is 5. So we're going to substitute that in. And then I want you to solve. Okay? So 3 times 5 is 15. 15 plus 2 is 17. Okay? Right here, substitute x. X is 2. Plus, what's my y? Y is 3. Okay, 2 plus 3 is 5. Right here, z. What is z? Z is 5. Minus x. X is 2. So 5 minus 2 is 3. All right. If you have any questions, ask me as we're going along here. All right. So if you look here, find the values of each expression by substituting 4 for x, 8 for y, and 10 for z. So here x is 4, here y is 8, and z is 10. I want you to try these 3 on your own and let me check it before you move on. Okay, you're going to substitute the number in for z, number in for x and y, and tell me what it is. Put the number in for z and x based off of these 3 given values. And let me check it before you move on.